There's a look at the storms that came through yesterday evening and their depiction on radar. And this was just a textbook linear multicell. The storm was pulsing about once every 10 or 15 minutes. But further out to the distance, in the western sky where you see this clearing, we actually had a new line of cells develop. And there you can see it coming together very rapidly. And that was the big show of the evening. So let's see what's happening right now across the U.S. Currently on our surface map, we've got a major frontal system moving through the Midwest, and the cold front itself extending all the way down into the Gulf Coast states. This is certainly an unusual pattern for mid-June. Normally about that time, a lot of these powerful systems stay up north, and the trailing fronts make it maybe as far south as Oklahoma, North Texas, Arkansas, Missouri. This one is just totally clear in Texas, and it's even off the map toward the bottom there, going through Monterrey and Saltillo, Mexico. Up to the north, the powerful low-pressure system producing a severe risk for parts of Michigan, Indiana, and Ohio. We'll cover that briefly. However, one issue involved in all this is the warm front is well up to the north, and we don't have any strongly backed flow anywhere except way up there in Quebec. So right away I can tell that may be a limiting factor for the activity out over the Midwest. But if there's strong enough shear, that can compensate for that to a certain extent. Out to the west, we have a powerful area of cold air advection moving through the Corn Belt into Illinois and Wisconsin there. Very cool day with 60s and northwest winds. And out to the west, we've got a large high-pressure system. A lot of this is Pacific air. And you can see the very mild conditions. 71 there at Denver. Yeah, that's pretty cool for this time of year for sure. 60s in Idaho. And to find the hot weather, we've actually got to go back to Arizona, where it looks like the continental tropical air is building in once again. A mild 96 degrees there at Phoenix, 98 at Yuma, but I would expect to see those temperatures start coming up tomorrow. Now, a good litmus test for the western U.S. is the San Joaquin Valley right in here. You can take a look at those temperatures, and we can see 87. I would say that's probably about average. Let's take a look at Wikipedia for Sacramento, where it's 87. Yeah, there's Sacramento. I actually lived there briefly when I was a kid. And there's the climate. June, hot, typical temperature, 87. Okay. And we got to consider it's about noon, so we're probably going to peak at about maybe 90. So these temperatures are seasonal to maybe on the slight warm side there. All right, so we've got a general idea of what's happening. Mild to slightly warm out west. Very cold in the central U.S. and very hot out east. And look at that. Yeah, 90 degrees out there in upstate New York. 5 degrees warmer than Dallas. That's something you don't often see in June. So overall, the upper air pattern is probably going to run something like this. And if we go by the typical location of jets, I might be looking at something like this. Typically, it intersects the active baroclinic system, and that's kind of what I'm predicting we're going to see on the upper air charts. And there's our afternoon charts thanks to pivotal weather. Jet stream is actually going well up north towards British Columbia. So that's useful information. You remember I told you, I think it was yesterday or the day before, that these deviations from your expectations, those are valuable. You remember how we were talking about maybe the jet being down in this area? This tells us that the ridge is actually built up pretty good. So the jet way up to the north. Down in the Midwest, it's about where we expected. It does cross over that baroclinic zone in Michigan, and it moves well up to the north over Quebec. Okay, so we've got a major shortwave ridge over New England, like that. Major shortwave trough Well, it looks like a couple of them. One there, another one kind of back over this area. And then a major ridge out over the western U.S. about like that. And we do see another important thing. We've got to start looking at the easterly flow aloft. That's very important in the summertime. So let's see what's happening in Texas. Well, we've got westerly flow. So the prevailing westerlies are set up all the way through the U.S. We have to go all the way down to south of Brownsville to find the actual subtropical high. And that's where the easterlies are, way down there. And we're going to start catching some of that maybe later in the month or in July. Now, there is another subtropical high there off the Carolinas coast, easterly flow there, and that connects back to that other high over northeastern Mexico. Well, things look busy up there in Michigan. We've got a moderate risk covering much of the state, extending down to the Toledo area. And checking through the text, you can see the focus is on bowing segments. Deep layer vertical shear favorable for supercells and bowing segments, given effective bulk shear of 40 to 50 knots. Photographs are long but straight with modest low-level shear. So it looks like the bulk shears are going to be the contributing factor. And individual isolated supercells, those are going to probably boil down to mesoscale accidents. Well, what do we see here on the visible satellite imagery? This is Michigan. You can see Lake Michigan over here, Lake Huron over here in red, and in green, Lake Erie. Detroit located about right here. Let's run this forward. This is about 3 or 4 hours of data. And we can see we've already got initiation. So that's not going to be a part of our forecast problem. Storms are already underway and the main convective element's running about like that. And we see something kind of unusual. Look at that. The anvil plumes being carried towards the northwest. And the reason for that, probably the upper level low is located to the west or southwest. And we've got basically an upper flow running about like that. Now, the low-level flow is probably from the same direction. It's probably flowing kind of like that. So already this is kind of a setup for unidirectional shear profiles. In other words, the winds are coming in out of the same direction from the low levels to the upper levels. Okay, and there's also propagation of that line towards the moisture, which is located out in that area there. Here's a look at the Detroit radar as we record this. As of this hour, it doesn't look like there's any major severe weather segments. There's a couple of isolated cells out ahead that are kind of strong. And I can see a slight bowing tendency on some of these cells. Some indication of that, indicating that there's probably some outflow dominance. You can see there's not any particularly strong reflectivities. And going down to the Indiana area, looks like we get into slightly more isolated cells. That one there south of Fort Wayne looks pretty strong. Let's pull up the radar in that area. Looking at the Fort Wayne NexRad, and now we're closer to the storms. Still not looking very severe at this time. Let's check for rotation. Yeah, checking on rotation there. Not much going on, really. And to sample the environment, we can take a look at the high-resolution rapid refresh model. The main issue is to make sure that it's verifying properly, and yeah, these convective elements are right about where we are finding them on the radar. The model objective analysis systems are very sophisticated, and unlike the 80s and 90s where it was pretty much hit or miss, these are going to give you a good idea of what the environment as a whole is doing. So what we want to do is go out ahead of the line and look at the environment, and especially pay attention to the winds. Okay, so this is somewhere west of Detroit, northwest of Detroit. You can see there's a lack of capping which kind of corresponds to what we're seeing on radar. Numerous cells out there. And we're also pretty far from the southwestern U.S., where a lot of the cap air tends to come from on the Great Plains. So it's normal to find very uncapped air out in the Midwest. As far as our capes, they're in the 2500 range, which is, those are definitely some high readings there. And our all-important wind flow. There it is right there on the photograph. We can see that the strong southerly winds are shortening the photograph somewhat. So that's helping to pack the trace into kind of a short line like that. So because of the deep effective inflow layer of the storm, this is all buoyant air here. So we're sweeping out kind of a large effective inflow layer, but that's through 3 kilometers. Overall, the SRH quantities are moderate. Also, not seeing a whole lot of curvature on that photograph. You know, we want to see shapes more like that, or like this. That would certainly be helpful for tornadic storms, but we don't really have that. Like I mentioned, it's kind of a straight line photograph. And as we go to the back of the storm back here, you can see those southeasterly winds aloft. And that's what's carrying our anvils out to the northwest. So let's take another inflow parcel. Let's go west-southwest of Detroit. There we're getting a little bit better SRH. And let's take a look at the storm relative winds, and that's going to be in this box right here. We can see the storm relative inflow layer is about 20 knots. That's going to be marginal to good. Mid-level storm relative flow is also marginal to good. And the 9 through 11 kilometer layer winds, those are kind of on the weak side, only about 22 knots there, and that puts the storm in the HP range. Let's go a little bit further north and look at that storm relative wind. We'll go north of Detroit towards Bay City, and we start picking up a little bit more storm relative anvil level winds, but we're still in the HP range. Now another factor, look at those decapes, 1300. Okay, that's significant. Let's go closer to Detroit, 1201, which is pretty high, and go further south towards the Toledo area, 1279. Okay, we've got high decapes. That means that the parcels coming down out of the downdrafts are very cold. See that downdraft temperature? You can see that downdraft temperature there of 62 degrees. So the outflows are going to be pretty strong out of these cells. So there's a lot of dry mid-level air that's going to be brought down to the surface. So where would we forecast the most severe weather? Well, going back to the soundings, the big thing that we're lacking is the curvature in the photograph. So we want to go to where there's better SRH, stronger southeasterly 1 kilometer wind. That would be important. High capes and high theta E's, that's not so important, especially since we're pretty uncapped and there's a boundary in place. It's really coming down to the low-level winds. Now, on Pivotal Weather and a lot of websites, we're not given the 925 millibar wind, and that would be important because that would give you the 1 kilometer flow. That's hard to get on a lot of websites. So I think the best thing you can do is use the surface flow for a proxy. Let's bring that up. So looking out here, where is the most backed flow? I don't think we have anything particularly favorable. It's all unidirectional. We can also go to SPC and look at their experimental products. 2-hour pressure change, that can tell you where you're having forcing aloft. Nothing very helpful in that pattern right now. We can also look at the divergence and vorticity, typically what you'll see is kind of a bullseye like you see right here in the divergence-convergence pattern, often co-located with the shading showing higher vorticity. And when you have a bullseye like that, that can tell you that there's pressure falls and cyclogenesis going on, and you'll often see a response in the wind flow through here. You'll see backing in that region. That favors severe weather, but I don't see anything like that. Everything looks linear, and the other problem is that a lot of these values are being produced by the outflow boundary. So now that we already have storms and outflow, we can't really tell much from the surface patterns. We'd have to look way out here, and it's kind of indeterminate. So I think at this point you're down to looking at observed data. Well, we can go to the METIS website, but that's not very useful for displaying meteorological data. I'm not sure what they're thinking there, but you actually have to hover over each one to get the winds. That's not very useful. Well, one thing you can do is you can go to the Weather Underground Wonder Map. That'll give you some wind plots. Of course, these plots are very oversimplified, but at least, this will give you a good idea of the wind flow. And we can see the winds out there are just kind of light and variable. There's a few outliers, but you should disregard them because in a lot of cases it's bad sighting of the wind equipment. Looks like the flow out here are a little more veered, so I would expect storms approaching that area to not quite be so severe. And then we go further south, maybe a slight bit of backing in the northwest counties of, looks like maybe this area here. That's southwest of Toledo, so that might be an area that I would keep an eye on. And of course you want to check your radar. So apparently this cell here, southwest of Ann Arbor, that may be coming together. It's an isolated cell out ahead of the line. Similar situation going on there near Pontiac. And of course the stuff further south, we would have to keep an eye on that. Okay, I think that's about all I've got for today. I see we're already up to about 14-15 minutes. So in closing, I will leave you with some drone footage. Hopefully you enjoy that, and we'll be back at you tomorrow with another edition of Forecast Lab. Have a great evening. Bye-bye.